Okay, so part two of logs. So they put some properties here. This is not the full list. In 6.3, we're going to talk about the product rule, the quotient rule, the power rule. But these are just more like basic properties of logs, which log base anything of 1 is 0, because that's asking a to what power is 1. Answer better be 0. Log base a of a is 1. Log base a of a to the x, and a to the log base a of x. Those two things that we've already been using. They call it a property, I call it its reason for existing. All right, and then the definition of common log and natural log. Common log is 10 to the, like base 10. Natural log is base e. So find the value of a common log mentally. They're log base 10s, so this is asking us to figure out what these numbers are, 10 to what power. So 1,000 has 3 zeros, so it is 10 to the third. So we get 3. How many 10s do you have to multiply? 3. Over here, we have 1,000,000. 1, 2, 3, 4, 5, 6. Yes, it equals 6. Because it is log base 10 of 10 to the 6th power. All right. So now we have, like back in 1073, beginning of the semester, we had two major types of domain restrictions. That was even root, typically square rooting a variable. We had to restrict the domain. Also, dividing by a variable. We had to restrict the domain so we didn't divide by 0. The third common restricted domain is from logarithms. We can't log 0 and we can't log negative numbers. So when we have log functions that have been shifted around, the question is, okay, what's my cutoff number? Like, what numbers can I only go past or go before? Which this cutout also turns out to be the horizontal asymptote, or sorry, the vertical asymptote, hand gesture, not word. So on these, when we're identifying the domain, we are literally taking whatever's inside the log, and I want to say that is strictly positive. So if x plus 3 must be greater than 0, then x must be greater than -3. So there's how we write it inside set builder notation. In interval notation, this would be from -3 to infinity. The number's bigger than -3. Same thing over here, except what we're taking the log of is a little more interesting. 5 minus 2x is greater than 0. So I'm going to do it the more error-prone way. We're going to minus 5 on both sides. So I have -2x is greater than -5. The next step, if it was an equation, would be to divide by -2. And we are going to do that, but inequalities have a weird little qualification to them. And that is, if you ever multiply or divide both sides by a negative, it flips the direction of the inequality. If I have, so let me just kind of thought bubble over here. If I have 1 is less than 2, and then I multiply both sides by -1, then I would have -1 and -2. Which one of those is bigger? -1 is closer to 0 than -2. It's closer to being positive. So when we multiply by a negative, which one's bigger now becomes the smaller. So over here, that means we need to flip that symbol over. So that weird loop-de-loop arrow is my symbol for flip the thing. So now we have x is less than positive 5/2. Now, if up here, instead of minusing 5, if I just added 2x to the other side and then divided by 2, I still would have had 5/2, but I would have had 5/2 is greater than x, which if I mirror the whole thing, x is less than 5/2. So as an interval, this is from negative infinity to 5/2. So it means that negative inside there flipped the graph left, right. All right. Stop this one. See you on the next one.